Have 1:30. Welcome back, everybody, after lunch. We have another session to do here, and to kick things off, we have Michael Jablonski, who is a systems engineer with Bechtel and is currently working on the Mobile Launcher 2 project in support of the NASA Artemis program. Previously, Michael has supported verification activities for the interim cryogenic propulsion stage, which is Artemis's second stage, the launch integration for the Boeing Starliner, and served in the U.S. Army fixing and flying helicopters. Please welcome Michael.
Thanks. Hey everyone, good afternoon. Welcome back from lunch. Hopefully this next conversation can keep everyone awake as we shake off the chicken wings and pizza from today. So as I was trying to think of what I wanted to do and talk about today, I think whenever I go into these events, I always like the presentations that are kind of real world. Here's what's actually happening. Here's the practical application of things. So that's kind of the mindset I took as I was trying to think of what I was going to say and how I was going to be presenting it. A lot of what we're going to talk about today is not necessarily specific to any single tool, but I'd say is associated with the processes to how do you make those tools work. So from a simple perspective of how do we perform verification activities, everyone's going to have their own tool sets, everyone's going to have their own internal processes, and kind of what I'm going to be talking here are some of the lessons learned that I've derived from basically working on this project over the last 5 years, and how do you make it work from a interface perspective, both with internal to the program, and then as well as external to the customer and whoever you're interfacing with. We already talked that. So the specific topics that we'll be going over, some of it's going to be some of the background on the projects, just to give you kind of a frame of reference of where I'm coming from, talk about some of the unique characteristics of this particular project, and then talk about, again, some of those best practices, as I'd like to say. So how do you define and block in those procedures in order to make something that's actually workable? And then finally, how do you grade that progress and that success at the end of the project? So hopefully we'll have some fun with that. All right. So hopefully everyone here is at least familiar or heard of the Artemis program. So this is the new mobile launcher that NASA has contracted Bechtel to build in support of that project. So back in about 2017, NASA had the crossroads decision that they had to make of, do they take the existing mobile launcher and modify it for the new and upcoming rocket they are hopefully going to be getting to utilize? The newer model would be about 40 feet taller, a little bit higher thrust at the end of the day, and a little bit more capable. So they made the decision to not modify the existing mobile launcher and to instead bid that out to build a new purpose-built launch pad for the Block 1B, then eventually Block 2 Artemis rockets. So the ones that are basically going to hopefully be taking people back to the moon and then maybe eventually Mars, depending on how things shake out. Bechtel was awarded that contract in 2019 for the design, procurement, and construction of that new mobile launcher. And I think that that's kind of the first takeaway from some of the unique characteristics of this, in that it was a completely clean sheet design for basically a 40-story tall structure that was going to be supporting this new launch vehicle. So as a result of that, there was a lot of what I'd say carryover from that first mobile launcher. The new one, the driving difference was going to be the height, and that it was going to be about 40 feet taller. And a lot of the, what I'd call guts of that system is going to be, I'll say, reuse. So a lot of the capabilities that you have for fueling the rocket, providing commodities to it, electrical control, signaling, that sort of thing. All that stuff was kind of derived from what had already been done on that first NASA mobile launcher. So as a result of that, NASA made the decision to flow down the requirement sets, not for basically the entire mobile launcher as a whole, but for each individual subsystem. So they retained that, I'd call it architectural control over the requirement set, such that they wanted something that was a little bit more interchangeable, a little bit more plug and play to what they had already done. So let's face it, they are trying to reuse some software, and in a lot of cases, they're trying to reuse certain pieces of hardware to alleviate having to redesign some of that stuff. As a result, you have a requirement set that I'd say is a little bit unique in that you have requirements that are split scope. Now, what I mean by that is if you have a requirement in a procurement specification, normally you'd want it to be exclusively what you want that vendor to build for you. In the case of this particular project, you find a lot of requirements that bleed over from that mobile launcher and go into other elements that are associated with that launch infrastructure. Some of them can bleed over into the rocket itself. Some of them can be tied to the launch pad infrastructure. Some of them can be tied to that control infrastructure that's actually going to be controlling and operating everything. So that forced us into a couple decisions that we had to make of how do we track and maintain that information of who's responsible for what. I'll talk about that in a little bit more later. Because of the architecture of it, there's a lot of interfaces that come into play. So the diagram in the lower right-hand corner is a thinned down version of the what I call context diagram that we use to track and maintain all the interfaces between different elements on the mobile launcher itself, because it interfaces with different elements that it's going to be supporting. So interfaces with the rocket, interfaces with the launch pad for how it gets cryogenic fuels from the pad infrastructure, command and control signals, electrical power. So all those things come in interface control documents, and that makes up the, I'd say, disproportionate amount of requirements that we have to deal with and track and maintain and ultimately eventually verify. Embedded in those, you're going to have your normal set of performance requirements. Now, what makes them a little bit unique here is there's not a lot of what I call active components on the mobile launcher itself. So unlike a power plant where you have a steam turbine that's trying to do some sort of direct function, the mobile launcher itself is, think of it as like a big extension cord or pipe extension where you're trying to get fuel from one area to another. So the performance requirements are very much driven by what are those commodities that you need for that end product. So in this case, think the rocket itself, and how do you get those cryogenic fuels to it? So those are your performance requirements that you're having to try and maintain, hopefully show that you can meet them at some point or another during those verification activities. Functional requirements, those are, again, embedded in kind of the interface themselves as far as what each subsystem is supposed to be doing and what it's supposed to be performing. So across the board, you have about 40 subsystems, depending on how you count, that are providing one function or another in support of either the operation of the launcher and what is actually being provided as a commodity or service to that rocket itself. All those functions, all those performance characteristics have to be met in what I would call some unique climate and environmental limitations. So first off, you have a metal structure that's sitting out on the Space Coast and very susceptible to corrosion and other unique environmental conditions that are present out there. Could be hurricanes, could even be sea turtles, which also have requirements for that, surprisingly enough. I'd say the one that drives most of the decisions is going to be your launch-induced environments. So you have a rocket that's generating upwards of millions of pounds of thrust, and it's creating a lot of wear and tear on the structure itself. So those launch-induced environments are considered for a lot of what's actually happening and how you're going to show that you actually can meet those performance requirements and hopefully not fail up until the point where the rocket leaves. Now, one of the fun things about this is the launch use environments that were incorporated at the beginning of the project. Eventually, when they launched that Artemis 1 mission, they did have to go through and actually update all those environments. So after the structure was designed, they had to go through and reanalyze and reassess it to show that the higher actual loads would actually be survivable. So as a result, part of this is how do we show that we meet these environments in this changing environment, and how do we show that we can meet these requirements on a contractual basis to the customer? So this is, I'd say, probably the big takeaway from this entire conversation today is how do you integrate these processes into a integrated process, both internal to an organization, but more importantly is how do you get that buy-in and support from the customer itself? So what I have here is kind of a summary of topics that I think are kind of good talking points, and kind of, some, you can trace them back to war stories or scars that occurred over the last few years of why do some of these things have to be defined in an environment where all you're doing is performing verification activities, right? So I think the first thing I'd say here is if you're performing verification activities, the first step is to make sure that you're writing everything down. Because a plan to say we're going to perform verifications is probably not a very good plan. And the reason is because you're going to be pulling from a lot of different disciplines over a lot of different organizations. And as a result, basic definitions could be applied or understood differently across different projects, programs, or whatever. So as you're trying to set up a verification plan, verification activities to support your project, make sure that you're grounding it in some sort of reality of what are the basic definitions that we're following. Some of them can be as simple as, your definitions of inspection, analysis, test, or demonstration. And as you talk to different disciplines, people with different backgrounds, you may find that there's different people who interpret those in different ways. So grounding that in a single location can alleviate some of those potential conversations that may cause added friction or problems. One particular example of this that I experienced was a status that we're using for specifying how complete a verification is and where it is. Little did I know that when that word was originally plugged in, I later learned that was a trigger word for NASA in certain cases, because they use that term differently. So as a result, by not having it clearly defined early on and clearly understood on both sides, it created a little bit of unnecessary friction. Moving down the list, defining the scope of verification. So once again, this is a case of just saying that you're going to perform verification activities may not necessarily be the best approach. So simple question, what has to be verified? To what level of detail? How are you going to verify specifications? Should you even be verifying design specifications or other sorts of documentation? So having that, I'd say, consolidated understanding across the board of what those verification activities are going to look like and how it's going to be presented is something that needs to be discussed earlier on in the process. Because by the time you're actually running testing and performing those activities later on, well, in some cases the contracts are signed, the money's been spent. So having that delineation of responsibilities can help streamline that process and make it a little bit easier for everyone to understand it. Likewise, who actually does have the approval authority to say that a verification is done and complete? So having that process defined, whether it's a self-approval where a project's just verifying everything internally so that they can keep accountability of that, or is there some sort of external approval that has to be had from the customer? So those are the types of processes that need to be hashed out well in advance so that everybody understands their specific responsibilities and that delineation of who's doing what. One of the things that should come out of that will be ground rules for how you're developing your, and you can't talk about anything in this conference without talking schema in some way. What's your schema going to look like, and what are the ground rules for how that's going to be structured? So some of that will guide how you're assigning responsibility, whether it be for verification activities, who's providing what, and you can help build that into the data set such that it can hopefully have a downstream purpose. Degree of automation. This is one that I put it down as kind of a fun talking point, but I think that after having sat through all the other presentations over the last day and a half, I think that I'm getting a whole different understanding of what this truly means. So in the case of the project I'm working on right now, it's a very, I'd say, containerized organization. There's not a lot of, we'll say, AI. There's not a lot of database interaction. So a lot of what takes place in there is a very manual process. So when you start talking verification activities and somebody's wanting to try and determine how far should you go in trying to document and prove compliance with a particular requirements, in some cases it could be it takes 1 or 2 documents to show compliance with that. In other cases, you could be literally looking at hundreds and hundreds of documents that come from vendors, suppliers, and other sources. And in an environment that's basically being handled in a very manual basis, that's not going to be very practical. It's not going to be cost effective, and it's going to take too much time and effort. So understanding the degree of automation that's available to you may help box in what that final solution is going to look like for how you're going to actually show that you meet requirements. That way you don't get too overly ambitious. Next up, you have the schedule. So this is what I would call out and say is probably the biggest friction points that I run into with my customer in how we're performing verification activities. So the model that Bechtel has been following is how do you burn down risk as early in the process as possible? So if I have a verification that is very strictly associated with the design, that's something that should be able to be closed much, much earlier in the process. And you don't necessarily need to wait for the hardware to be built. You don't necessarily need to wait till the very end of the project. And the mindset that's coming from the customer is they will only close things when everything's built, when everything's tested, when everything's done. And depending on that level of requirements, if the requirement says that you need to use certain color insulation on a cable, do you really need to wait for it to be built and tested in order to say that you're good in that regard? And I think the answer is no. You can probably burn down that risk earlier on. So what we've done is we've spread out the verification activities over major milestones. We use about 3 different major milestones, one after the design is complete, one that is going to be coming up to us in a couple of months when the major construction activities are complete. And then finally, that final turnover just before we hand over the hardware to the customer. So by breaking up into those chunks, we incrementally buy down that risk, and we basically pin the rose on whoever's providing that verification evidence at the time when they can affect it most readily. And then finally, this is kind of the last piece that I'll call out, and it's kind of my favorite. Plan out the verification activities. So what do I mean by that? You take a large system and then you refine those requirements down across multiple subsystems. There's going to be certain parallels amongst requirements, right? So those launch induced environments requirements, those climate requirements for sitting out on the coast, every single subsystem is going to have to show compliance with that in some way, shape, or form. By planning out the actual executable work that's going to be done by the systems engineers and what's going to be plugged into the tool, the earlier you start planning that, the earlier you can start coming up with those economies of scale. So instead of coming up with 5 different ways to verify whether you meet that natural environments requirement, you can come up with one consolidated way that's equitable across the entire project. And that'll leverage a lot of efficiencies that can be had. And you don't have to basically reinvent the wheel every time. So personally, I think out of all these, that bottom one is kind of the most important as it relates to the work that, a lot of people spend day to day. How do you take the requirements? How do you figure out how to verify them? And then how do you write it down to document that plan? Ultimately, the goal here is how do you manage risk? So why else would we be doing this, right? It's not to just spend money. It's not to make the engineering or construction group lives difficult by giving them extra tasks to do. It's how do we burn down risk and how do we show that we're actually doing what we're contracted to do? So by coming up with that, we'll say consolidated plan to say how you're going to verify everything start to finish, it alleviates some of those uncertainties and helps shake out some of those unknowns before you actually get to the testing, before you get to the construction, before you get to those places where you've spent money and you basically have to redo work. So it's ultimately, how do you reduce risk? Second, how do you establish consistency across the projects? So I'm in a good position where I have basically, like I said, about 40 subsystems that all have to be verified to show that we meet this set of requirements. And having a dozen different systems engineers trying to implement this guidance, if you just let everybody run with it, you're going to get a lot of different design solutions. Those may not necessarily help or work out and help the organization as a whole because different design decisions may be implemented in different ways. If you have one systems engineer that comes out and says that we need to have material coupons left out on the coast so that we can show compliance with those natural environments requirements, that's probably not really practical. So that's where you need to box people in to keep them from not spending needless money, time, or effort doing things that may not necessarily be helpful or constructive. And then lastly, that organizational alignments. So like I said earlier, the one major friction point that I'd call out would be, when are verifications going to be completed between you and the customer? Who's that approval authority? So how do you get that buy-in from the associated stakeholders as early as possible, such that there's not uncertainty with who has the actual approval authority? Does the customer have veto authority in the design, or is there certain aspects of it that they really shouldn't be or can't be controlling? So that alignment piece, I think, is a lot of something that tends to be overlooked and something that not a lot of effort is put into early on until it actually becomes a problem. So again, provide a little foresight and plan for the end states. All right, moving on. So here's my obligatory slide showing the schema. So this is a class diagram that I put together to show a snippet of the architecture that we're using for managing our data. The reason why I threw this in here was to help provide some context with some of those ground rules that I mentioned earlier and how we apply them. So starting in the top middle of the slide, we have our requirements class. And one of the ground rules that we have implemented is every single requirement will have exactly one or more verifications. So the reason why we did this is because it's a byproduct of that requirement sets that we were originally provided. Because NASA maintains that architectural requirement sets authority, we didn't really have to refine or break down requirements in any way. So the major thing that we had to do was how do we verify all of them? So this was a really good exercise in how do you efficiently come in, figure out how to verify and address that certain requirements, and you don't have to really worry about that middle step of did we refine the requirements down correctly. Next, on the right-hand side, we have an organization. So part of delineating responsibility and who's responsible for what, every single verification has at least one organization applied to it so that we can pin the rows on and then hopefully take the data and eventually assign responsibility to who's responsible for what. That feeds into the artifacts that they're going to be generating. I'd say this is probably one of my favorite aspects of InnoSlate, and that if you map this out correctly, it really simplifies that design review process of every time a document comes across your desk, rather than trying to guess what requirements relate to it. You can go into the tool, you can run your queries, and it basically gives you your checklist of here's every single requirement that needs to be bought off. So that's something I very much like. And then last, we have a time frame. So in this case, this is the due dates. When's that verification due? When does it have to be turned over to the customer? And this is that piece of information that's pulled from, some of the other data sources within the project itself. The last thing here is going to be your verification itself. I'd break it up into two pieces. So one of them is going to be your plan. What's your plan for verifying the requirements? And then what's your closure statements? That plan can be broken up into multiple attributes. So in our case, it's what are those document types that you're trying to use to verify a requirement? So what do you need from that verification owning organization? Second is going to be what are your acceptance criteria? What does the test have to do? What are you looking for in a document? And where the case may be that's, you're needing to actually show that you meet the requirements. And then third piece is going to be what are those notes, caveats, exceptions, or other things that may be associated with that requirements. So in some cases, in my case, it's how do you define what the customer is responsible for? It's how do you delineate responsibility? How do you add caveats to a requirement because the requirement is poorly written? So different things that you can do to document and articulate what actually is being verified. And then lastly, your closure statements. So the closure statement is, to me, a 3 to 5 sentence paragraph that explains the use of the documents that you're mapping out to that verification and saying why you actually meet a requirements. So I think anybody who's done any sort of verification work has seen at one point or another that they're handed a list of 2,000 pages worth of documentation and they say, yep, we're good, everything's perfect in here. Well, but then you have that 2,000 page non-searchable PDF that's, all right, we'll prove it. So that closure statement is meant to explain that use of that document and where exactly you can go in there to find it to help build that traceability to show why you actually met it and kind of that rationale for how you actually meet the requirement. So what I have here is what I would call a grading rubric to show how I actually meet a requirement and what level of detail needs to go into it. And on the top half of the screen, you're going to have your plan. So what are your notes, what are your documents, what are you looking for to show that you actually meet a requirement? On the bottom side is going to be your closure statements. Now, since I'm running a little short on time, so as you start building this, if your plan is to go look at a drawing, or even better yet, so I'm just going to use everything to verify the requirement, how does that neck you down in some sort of a way to show what you're actually looking for? I'd say in this case, the systems engineer may not necessarily understand what the requirement means, nor understand what kind of documentation is going to be generated to show that the meeting is. So building this out, what's the right level of detail? Do you list a document type? Do you list those exceptions, those notes, the acceptance criteria? Once you start adding in a little bit more detail, such as document numbers, that may not necessarily be helpful either. So if you have to update the plan every time a document is changed, updated, superseded, you may now have more redundant work that's going in there, and you're now over planning with not a whole lot of value. And I'd say probably the other end of the spectrum is what happens when somebody comes out and starts listing everything in the kitchen sink. So this is a case of, once again, maybe the requirement's not specific enough to allow you to know what you're looking at. On that closure statement side of things, simply stating that, yeah, you meet the requirement may not necessarily be a good approach either. Because again, what are you looking for? What level of detail are you looking at? On the other end of the spectrum, that once upon a time narrative that says, here's how everything works, here's the history of it. Now you're starting to maybe add things that aren't written down, and you're starting to pontificate on things that, maybe don't necessarily relate to the requirement. So that's a case where you're probably going into too much detail. So I'd say that probably the sweet spot is probably what I have in the middle. So identify the drawing, identify, those boundaries for what the verification is actually going to look like. And then can you identify the sheets, zone, page, sections, whatever the case may be, in the final objective evidence, and can you explain it? And if you can do that, then I'd say the litmus test is probably pretty good, that the requirement's reasonable, the systems engineer understands it, and you've probably implemented it effectively. So here's my one sales pitch to Steve. Unfortunately, he's not in the room. If you can add a grading rubric in the slate so they can grade verifications, that might be the next fun thing that he could implement. So with that, what questions you guys have?
All right, one question.
One question. Yes.
You would use a test center to lay all the details out? Verification plan?
Funny enough, we do not use test center. So that was a byproduct of how the data was structured for us. And at the time, we didn't have a good understanding of those milestones. So being able to chunk up the data in something that would go into test center, we found that we were moving back and forth too much between it's going to happen during this milestone versus this other milestone versus, this other activity. So that planning wasn't quite done as well as it could have been early on in the process. So we weren't able to leverage that particular tool as well as we could have.
Okay.
All right.
Thanks, Michael. Thanks. Okay, our next speaker is Tyler, is it Lovelady?
Yes.
All right. Is an INCOSE certified systems engineering professional and vice president of business development at VETS LLC, a service disabled veteran owned small business specializing in digital engineering and MBSE solutions for defense and industry. With over a decade of experience in systems engineering and acquisition, Tyler is a recognized leader in the model-based transformation of complex mission-critical programs. During his tenure as an Army civilian, Tyler served as the MBSE lead for the Future Long-Range Assault Aircraft, guiding the development of the government-furnished information model and integrating government, OEM, and stakeholder architectures to support lifecycle acquisition and MOSA alignment. He played a pivotal role in shaping FLRAA's shift from traditional systems engineering toward model-based practices at scale. At VETS LLC, Tyler focuses on expanding MBSE capabilities across the DoD, DOE, and commercial sectors, delivering training, consulting, and digital engineering as a service through cloud-based environments. He currently serves as the Corporate Relations Director for INCOSE Huntsville chapter, helping industry and government teams bridge the gap between strategy, architecture, and execution through collaborative systems thinking. Tyler is passionate about leadership, digital transformation, and empowering teams to adopt digital engineering in practical, scalable ways. Please welcome Tyler.
Thank you. If I would have known that would have been red, I would have not had it be so long. I'm sorry. Yeah, thanks for having me, guys. I think what was published was probably an inflated title. This is really, I think, a commentary on our past experience in acquisition. So that's primarily my background. Government acquisition. I was a civilian for about 7 years in Army aviation. Got brought in, learned systems engineering, and was asked, hey, this is a big opportunity for you. You need to figure out this MBSE thing. About 2018. Oh yeah, and by the way, we're accelerating acquisition. So good luck. But then I left. Was in there about 7 years. I left Army aviation to go on the industry side, and I had this idea to talk about really this broader implication of how we adopt MBSE in our holistic strategy, and really how that started by asking a lot more questions as far as our overarching strategy is how is this going to connect to other things? Like how are we going to set up solutions to enable our acquisition strategy and efforts to get through these milestone gate reviews that we have to do rather quickly now. And so I reached out to my good friend Justin on this idea because I thought it might be a lot of the stuff we were working was getting through rapid acquisition design efforts from the software component spec perspective. And we were running into some rather, I guess, some big challenges as far as like being able to prove that we were in compliance, right? Uncertainty. So, do you want to say anything?
No.
Okay. I'm gonna have to hand this off to you, so the mic. All right, so this point here is just proving that, yeah, we're all trying to adopt digital engineering, MBSE. We're also being asked to do MOSA in these things, and a lot of these in these acquisitions, and some people are adopting MOSA and implementing MOSA strategy by developing reference architectures and how are we doing that, and what tools are we using, et cetera. In my past experience, it was we were using contractual methodologies or contractual mechanisms like OTAs and going through an MTA. So, and this right here is what we've seen in, I guess, Secretary of Defense just released a memo about software acquisition pathways. So it's just further proving that the government's not slowing down acquisition, they're just ramping up, and they're going to start using more and more commercial solutions openings to get their products faster. And then, and because we were going faster without having a holistic like strategy and approach for adopting these tools, you might have an over reliance on some simplification of how things are going to work by leveraging MBSE. You'll see on the next slide, a lot of things is we often thought that a thread was going to be solved by MBSE alone or a tool, et cetera. So put the point there, tool does not equal a strategy. All right, so title MBSE versus digital thread. So this is coming from a circa 2018, we're adopting System L, we're pre-milestone A, and we are saying, hey, we're going to leverage a tool. In this case, it was a KM Enterprise Architecture, and we were going to use it from the very beginning to decompose our CDD to understand our user requirements and really implement and the systems engineering process, the left side of the B, in that tooling. And so early on, leadership, I've been hearing a lot of things this conference about like paradigm shifts, ontologies, all this. And these all contributed, I think, to like some of the decisions that were made. There was an over-reliance on MBSE solving this thread thing that we're trying to do. Hey, you have requirements, you have behavior, functions, you have entities or blocks, relationships. It's all there. And then it oversimplified, I think, what we were able to willingly achieve. And then when we got accelerated, what happened was it became evidently clear rather quickly that there was a lack of a holistic tooling strategy. When I say tooling strategy, I'm thinking like IT infrastructure, all that advocacy that has to go on up front, that we've seen that hump. Have you guys seen that chart where it's like, hey, MBSE or digital engineering is rather expensive early on and it saves you money on the back end? Well, those are like the things that, I don't think at the time people were really able to grasp. And so, we're talking like digital engineering, and we'll call them DEE, digital engineering environments, or cloud computing, all those types of things. We're seeing the use of AWS GovCloud, Azure GovCloud to sort of manage an environment. Like that was all talked about, but wasn't understood as its level of adoption from an enterprise perspective. And so that lack of holistic tooling strategy, because of an over-reliance on MBSE early on, created a bottleneck once the contract was executed. We were sharing data between, the government, OEM. So the government had models that they produced as part of their RFP. They provided that to the government. And even so, the government received S&T level type models that they, like reference architecture models that they were using to inform their RFP. So you had 3 different entities, meaning organizations, with 3 different management strategies as far as these models go that weren't necessarily informing each other. So when we provided it to the OEM, there was a bottleneck even taking receipt of procedural data that in this form was model-based. And it was, you know, a bottleneck from we didn't have the necessary tools in place on the side to, you know, that was managed the same way, or IT infrastructure resourcing from an IT perspective to offload the burden, because the PM's whole job is to manage risk and do impact assessment as far as getting us from one phase in the program to the next. And yeah, so you want to say anything on?
Yeah, you cube.
Go to the next
You want to go to the cube?
What?
I can use.
Yeah, so,
Yeah. I can use.
oh, your cube. Yeah, there you
Yeah, no, I think this is a good problem framing, I guess. That kind of as we go through these slides, we kind of get into how we tried to fill the gap. So
Yeah.
But yeah, I mean, bottom line is there is foresight for utilization of MBSE at large, at scale, but no real, you know, how to get started, right? Nobody did an ROI assessment. We've talked a lot in other sessions about NCOSI's capability matrix in terms of how you can approach MBSE transition. We've talked about that, Zendaya, and there's a couple others. None of that was done. It's just sort of a determination on, hey, I like, at the time, Magic Draw more than Sparks, and I'm going to start using it to develop use cases, and it kind of just rolled into a snowball. Nobody thought about plot tree models, 3D models, drawings, anything like that. So.
Yeah. That one graphic down there is trying to the one where you see the system level CAD, FBA does not equal. This is really a graphic representing like 2 disparate environments that, you know, may have some you know, strategy as far as integrating with things here, but if you don't inform the other and how those things are integrated, it doesn't matter, right? All right, next one. All right.
Yeah, so this kind of brings into, well, what did we do about it, right? So we talked pretty much all about the dilemma with bottlenecks created or inability to take receipt of data file formats from other tools like CAFTA or Bechtel Plus or, you know, 3DX. So we had to look at it in terms of use cases. So what we wanted was the same level of openness and agility that we tried to stipulate in contracts for open systems with things like modular open system approaches. We needed to start doing the same thing for the tooling vendors. We didn't shape any of that over the S&T years for the program. We only thought about the weapon system. And that's still being done today. Is we're locking ourselves to 1 or 2 tools for open system architectures, right? So it makes absolute 0 sense. And when we look at what's happening with acquisition guidance, people want to go faster. They want to leverage more commercial technologies. So we have to do more due diligence in terms of what we're getting and why, and then how it all integrates together, because we can't just go buy every tool that every OEM has, right? So essentially 2 ways, right? There's the acquisition use cases for the program, but then there's the operational use cases for the weapon system. And that's where we actually walked the dog on. Well, I have stakeholders. I have an airworthiness authority. I have a separate office that does safety. I have the MBSE team. I have software engineers, systems engineers, logistics. But I have other divisions in my organization that they don't need access to all the same data. So we had to essentially do use case diagrams internally for ourselves. And essentially, well, who touches what and why, and what interconnectedness do they desire, I guess, to get the complete picture of that. What they're taking receipt of from the OEM or the contractor to satisfy the requirements of the statement of work. So what we started to do is characterize the digital thread in terms of digital thread transactions, to where we could actually enumerate in a step-by-step process what matters and at what point in the digital thread it matters, and then who cares about it. And again, this was just the top level of a system level supply chain. This wasn't getting into like, you know, say Lockheed was there, say Collins was there, say Bell was there. It wasn't actually getting into like their tool chain for development and verification. We were just looking at a system level, how do we bring this thing together? So that led us to the transactions view. And then it allowed us to look in a disciplinary, sort of perspective on, how to approach the things that matter for digital threats. So then we can go, unless you had something to add for this chart, we can go to the next slide.
Well, I was just gonna, so I mean, if you guys have seen this chart, this was out of the DoD 5000.97 OSD. The point down there, the thread must be reproduced by the end user. So there was also this assumption that, we're going to leverage toolings like Syndea that are a digital thread tool. But if you don't actually, and those were, I don't know if you guys are familiar with like PEO structure, but they are higher headquarters, and then they don't really manage the acquisitions of the PMs, but they support the acquisitions of all the PMs. Sometimes, but support it's a loose term. They provide IT services. They provide, cognitive review of, RFP documentation that's going to go out, that level of support. And there was like an assumption that, we can leverage some digital thread tooling provided at the enterprise to our PMs to satisfy some digital thread whenever you take some receipt of all this disconnected data, that it's just going to magically reconnect back up, right? We found out that early on that was not going to have the case, because my OEM is not planning for that, and they're not, required to do that contractually. It's moot. So
and I guess one last is on the use cases. It didn't matter if it was in Cameo, Interslate, or anything else. At the time, we had access to Cameo, so we developed use cases with actors with interconnected relationships in Cameo. But the main was there was an entire use case for a technical data package for the weapon system. There was one too many of those. It was not just how do I sustain the aircraft, but how do I take receipt of gigabytes or actually terabytes of data. The next slide. So one of the examples, which is what we're talking about airworthiness here, is that was sort of the catalyst, working with Tyler and his MBSE lead capacity on the government side to sort of open the aperture on what we were worrying about and why. So the example we would go through to make this message more relatable to our enterprise level overlords, as well as the respective leads in the office, is, well, let's just walk the dog on something like a software requirement spec. So software high-level requirements to achieve, some level of airworthiness, right? I have data item descriptions that drive what content I need within that, but that SRS is part of a bigger life cycle of data I have to provide to substantiate with this aircraft. This is just trying to figure out the HLRs for the software. This isn't low requirements. This is the test cases. This is the test results. And the thing we're finding is I can't impose the rigor that the regulatory or statutory airworthiness requirements ask of me on the requirements themselves, where I can have atomic level source control of the requirement in the tool we have in Cameo. So on his side of the fence, they're saying, Tyler, Cameo is the source of truth. Everything's going to go in Cameo. On my side of the fence is all my vendors are using a tool dedicated for requirements management, because in Cameo, I can't trust a checksum for a project when it gets committed, when it gets saved down. I can't go and reverse look at the history at an individual element ID. So that right there put me in non-compliance with my airworthiness objectives for requirements. So huge issue. So that was the first little snowball full of rocks that began to roll. And that led to, okay, well, we have to look at this higher level, because then there were other implications with system safety that we got into. So this is just one example, but it was a significant problem. And different vendors have solved it, different ways. It was just, in this case, it had not even been thought of.
Yeah. And I mean, to kind of pull on that thread even more, if you guys have used Cameo and you save down a model from like Teamwork Cloud for whatever reason, that's a snapshot in time. And it's even compounded when these models are either rather large and they're filled, like he was saying, to the atomic level. He's trying to track requirements change management. If you have, it's like a snapshot from a model level. So you might have 100 requirements in one model that you've now just lost lost history of because of snaving down from a snapshot perspective. And that's what we're taking receipt of on the government side, which was tied to the Seadrill. So, did you?
I'll just exemplify a couple of these for the sake of time. I think we went through most of these, but like the metadata disparities between the requirements management toolings. A good example of that is like a derived relationship in Cameo is not the same thing as a derived requirement per RTC AD 178. So In NIST world, which is sort of what Cameo based its relationship off of, it has a relationship, right, to a parent. In RTCA world, or safety framework world, a driver requirement does not have a parent on purpose, and it gets justified. So when I'm synchronizing snapshots via Data Hub, which, by the way, introduces other complications with respect to things like qualified tooling that you have to deal with in the airworthiness community, it doesn't work. And even when it does get synchronized, there's bugs that are induced. So all these things just don't give my airworthiness authority confidence. It doesn't give the PM confidence. And that was, I mean, we don't know how many times we use that example. So we touched on DO331. That's what I'm talking about. That's a whole standard related tool call. We talked about CMQA. We talked about the driver requirements. So this is, I mean, this is just tip of the iceberg, but this is really what was driving the conversation. And the data modeling piece, that's a whole separate presentation, right? Because then you get into like semantic disparities with domain-specific data models and things like that, and differences in notation and versions. But bottom line is, it couldn't be solved with one tool, and there was sort of a reverse osmosis we were trying to make happen with our leadership.
Yeah, and then on top of that, trying to keep the workforce bought in that MBSE is good, right? We were dealing because of these, like this was over the course of about 7 years.
Yep.
Yeah. For this one.
And then I'll be really quick on this one. So the approach we did, don't throw things at me because this is in a spreadsheet. I just had my options in terms of the points that I was going to pick. But what we did is we just kind of looked at, well, what do I have to know in terms of what we have to take receipt of? So what's the title of the thing the OEM is using for that content related to the technical data package? That was the first stop. It's like, well, what's it even called, right? What's the purpose of it? What's the native file format of it? Is there an open equivalent for that native file format that allows me to use that data in like an interoperable fashion or open fashion? Most of the time, the answer was no. So everything in red in that snippet was everything that had not been thought of for that acquisition. We're talking multi-billion-dollar acquisition. So then we get to the descriptive content. What the heck is it even doing? Then we looked at which stakeholder cared about it. And this is essentially what got into a use case. And then we looked at, was our program executive office enterprise even tracking the need to support it? And that, I don't know how many weeks we spent with those guys talking about, why we need something. And it was just different perspective, right? It's like, well, do you really need it? It's like, yeah, we need it. It's on contract. So I would reference these tidbits later on, but these are just sort of like, the must-haves when doing this approach. I would absolutely do that approach again, but I'd probably do it at something like Untitled.
I mean, they're just structured that way to provide support to the PMs, but they're not necessarily vested in every single day. Their perspective is different. They're trying to just provide higher level support, infrastructure wise, or even just resourcing people to review data, but they don't necessarily intimately involved in the nuances of the data day to day or the acquisition strategy to help you, move that needle forward.
Yeah, we're not, one last, I guess, nugget on this. We're not even talking about building the thing. Like I'm not putting like compilers, right, and requirements database tools there or anything like that. I'm just talking about for the system level. We didn't even have that. So just to take receipt of the representation for that snapshot in time for that fielded thing.
Yeah.
It was difficult to have. So this is why we did this approach. This is why we had these takeaways. And if we could plan all over again, we'd approach it this way.
All right. This is a little bit about me and kind of our partnership with Wind River. VETS is a digital engineering solutions provider. Most of our competencies or background are like acquisition related systems engineering. Mine on the aviation side, a lot of folks have supported like Sentinel programs. The couple of partnerships we have here is this nonprofit DigitalWorks. So really this three-pronged approach here is helping, it's offering solutions like lower the barrier of entry, increase the adoption rate. So DigitalWorks nonprofit, they offer training. They partner with different training providers. We partner with Enola on training. The partners are trying to set up a digital engineering cloud environment to essentially make more available from like an educational license perspective. Many different systems engineering tools. So you can come and try a tool before you buy it, for example. And then on the other side, we have a JV where we're trying to offer competitive cloud IL5 prices to host these. environments. You know, that's really an answer to some of the IT infrastructure costs related that we've seen in terms of executing acquisitions rather quickly. And the real thing is like, oh, I need this tool that I didn't plan for. I now have to go through a 90-day software approval cycle to do that. It's an offering that says they would be scalable, accessible. Accessible is one. You know, the Airworthiness Authority, getting them involved early. We receive seed roles, and they're on a separate network, and you don't realize the issues that you have, even just being on the same arsenal. Getting those guys in was a rather headache, and it was like over a week where saying like, oh, we have 300 airworthiness subject matter experts and need to get in and review this data. That's on a behind this firewall. In other words, is looking at a tailored cloud-based approach to offer and be program centric that can satisfy your accessibility requirements for your stakeholders, OEM, sub-tier suppliers, et cetera. So 5 minutes, yeah.
And just the Wind River, like, so what, why this was sort of attractive is there's all kinds of Wind River at that level, the software stack, right? There's all separate tools to build that software, to sustain the software, you know, evaluate our requirements, our spec, you know, our design details. So what VETS provides is like your services, like SME access for the training wheels that the government needs essentially when they're dealing with a commercial product that they're unfamiliar with. Digital Works provide this sort of non-profit entity and sort of facility that they can use and the government can use to essentially educate themselves on that new thing.
Yep.
And then once they decide whether or not they need it or not, or like we were talking about the receipt of the native file format for that tool, model-based or not, then they can productize it in Venom. And that's sort of my understanding as far as where Wind River come to play, because it's rare that in my case, the government's going to take our compilation tools, right? Because they're getting the final thing. Yeah. But if they need it, this is sort of like that sequence of events from top left to right.
Yes, that's correct. Thanks, Justin. Yeah, and in Digital Works, like we were trying to, the partnership was trying to get like CEMIX on that cloud to help offer, training and availability for folks that might not be familiar with it. We've also talked with Spec and Liz and Dr. Dam about, Slate as well, because, Slate's a great tool. Anyway, so it's trying to be an offering for folks to come and learn and be a safe space to help increase that adoption rate for these types of toolings, where you're trying to figure out early on in the adoption, okay, to what level do I actually involve MBSE at all, or how detailed do I go? Your minimum viable product example is something that would be of interest, to get on there, provide out there. So it's a good way to articulate that. So anyway, that's it for this. Any questions?
No questions?
Great, thank you.